So we've seen how integrals tell us the area beneath the graph of a function and above the x-axis, and also between some numbers, right? So for example, here we have a to b. So I keep using this example, y equals x squared, so I drew it here. So for example, this integral, this notation, tells me I'm looking for the area beneath the function x squared and between a and b, so here's a and b, and so I'm looking at this area right here, okay? So notice it says area beneath x squared, between a and b, but it does also say above the x-axis, okay? So integrals can actually tell whether or not a function is above or below the x-axis, right? So if you're looking at a function that's completely above the x-axis, like we have here, then the integral is just going to tell you exactly the area between the x-axis, the graph of the function, and between the boundaries that you have set, right? So one thing you can consider and wonder about is what happens when you take the graph of the parabola and maybe shift it downwards, right? So what happens if we have a parabola that's actually going and dipping below the x-axis? Okay. So in that situation, we have maybe a graph like this. So this is the graph of y equals x squared minus 2. So it's still a parabola, it's just been shifted down by 2 units, and if you look carefully down here, that's a minus 2 on there. Okay, so in this situation, the integral still tells us something about area, but it's a little bit more complicated. So the parts of, so say for example, we're wondering about the integral from minus 2 to 2. Right, so maybe we care about the integral from minus 2 to 2 of x squared minus 2 dx. So this integral is going to be the area in these two little pieces, right? So here, this part of the graph is above the x-axis, right? So there I'm still going to get just this area, right? Beneath the graph of the function of the parabola, but still above the x-axis, right? So I'm going to get this regular old part for the part of the graph that's above the x-axis, okay? So area, maybe I'll write something like this, right? So maybe we'll put it in green so it matches. So area in green. Okay, so it's going to be the area in green. And then this area beneath the x-axis, so the integral actually tells us this area here, except it tells us this area with a negative sign. So because this graph dips below the x-axis, this area down here is still the area bounded by the graph of the function and the x-axis, right? Except this time the graph of the function is below, so the x-axis is above, right? So this area here actually gets counted as negative area. So here in the integral is going to tell us the green area, and then it's going to be minus the area in red. Okay. So this is what the integral is going to tell us, right? And this is a general summary of what I just said, right? So if the graph of the function is completely above the x-axis, then this integral is going to tell us the area of the region bounded by the graph of the function, the x-axis, and between a and b. If we just have a regular old function and we don't know anything about it being above the x-axis, so maybe it does dip below the x-axis, then the area is going to be, or this integral is going to be the area above the x-axis minus the area below the x-axis, right? So something like this. And we'll see this idea come up in a few of the examples that